Being a swimmer for a very long time, I find that coaches will often give feedback to swimmers to improve their technique. Yet oftentimes during training, feedback such as pull harder or higher recovery are difficult for swimmers, especially juniors, to understand and visualize, leading them to be inefficient. I wanted to solve this issue using engineering. I first did research and tried to find existing solutions. None were to my liking. However, I was inspired by a previous robot that I built, which could be controlled to move in the water by an app and was lightweight. It moved with the swimmer and it didn't require a person going underwater and inexpensive. I thought that if I could mount a camera on top of the robot, then I could film swimmers underwater whilst they swam and then show them their footage so that coaches could point out their mistake easier to learn. This was my big idea, and I built a 3D model of it on Rhinoceros. Yet I realized building my own robot from the ground up was unnecessary. So I chose an alternative of building on top of an RC boat, which served the same purpose, and then I drew a blueprint of an adjustable mount to house a camera underwater. I brought all the materials, and measured the dimensions of the boat and the camera, using Fusion 360 to create a clamp which could slide onto the boat, and an adjustable length tube extending underwater like a telescopic handle, attaching to the camera frame. I used PLA to print, and this was my final product. I went into the process of testing in our local pool and designed some flaws. Firstly, we had failed to consider the impact of the mount on the aerodynamics and center of gravity on the boat. Therefore, it went in circles rather than forward. Secondly, the remote-controlled signal on the Bluetooth of the phone couldn't reach the camera underwater, meaning that the camera didn't activate. After research, I found that Bluetooth and Wi-Fi signals could not pass through underwater. Afterwards, I ditched the camera and found another solution. Fishing cameras, which had wireless signaling device above the water. I then redesigned the original 3D mount for the camera, added another mount for the cables and Velcro on top of the boat. I tested for buoyancy to ensure that the placement was balanced, and after printing and assembling, my improved version was done. I tested it in the water and with some young swimmers, and the coach said that the robot made it easier for them to point out areas for improvement, and the students were able to visualize their mistakes, creating a better learning experience.
看到这个视频，他就知道自己刚刚做的动作到底有没有做对，他看了就知道了自己腿弯了，对吧？但如果我跟他说你腿弯了，他有可能不一定接受自己做的对的，但是你给他看他视频有证据了嘛，他就知道了啊，我是做的不好，他就可以。I'm
currently able to work on continuing testing with larger samples and collecting more footage. My goal for the project is eventually being able to create a software which could analyze the footage and allow coaches to annotate.